Number 1 is asking which graph represents a proportional relationship. Remember, graphs of a proportional relationship will be a straight line and it will go through the origin. Based on that, decide which of those 4 represents a proportional relationship. For number 2, it says the graph shows the cost in dollars of pounds of blueberries, which is a proportional relationship, and it wants you to select all the true statements. So take a look at the graph. They give you 1 point, $16.50 for 6 pounds of blueberries. Because we can see on the graph that, let me get my pen ready, C is the cost, W is the weight, so I can fill that in if it's helpful. So weight in, we said pounds, and cost, of course, is in dollars. So imagine this would be the x-axis, this would be the y-axis. Our coordinates are always x and then y first, so this $16.50 is the cost for this many pounds, so $16.50 for 6 pounds of blueberries. All right, let's look at our choices. 1 pound of blueberries costs $2.75. Well, to find the price of 1 pound, you have to find your unit rate. Your unit rate is always y divided by x. In this case, the y is $16.50 and the x is 6. So if you take $16.50 and divide it by 6, if that is $2.75, then A would be correct. 1 pound of blueberries would cost $2.75. Got to do the math because I don't have a calculator in front of me and I'm not going to tell you if it's right or wrong. So do the math. B, 2.75 pounds of blueberries costs $1. So that would mean, for y over x, it would be 1 over 2.75. That would be the opposite of unit rate, wouldn't it? Because remember, unit rate is where the 1 is in the denominator. So on your graph, that would be, would be pretty low. So this coordinate, 2.75 pounds of blueberries costs $1. That would be the coordinate 2.75 comma 1. Is that going to work? If you divide 1 divided by 2.75, is that the same as your unit rate? Remember, your unit rate is at $16.50 divided by 6. So if this is equal to that when you divide, then yeah, B would be true. But you got to do the math. All right, 5 pounds of blueberries cost $15.50. Well, you're going to notice we're going to talk about the unit rate a lot. Let me make some room here. So the way we can check to see if this one is true, if C is true, we're going to do a little multiplication. Unit rate tells us the price for 1 pound. So for C, they want to know the price for 5 pounds, or we want to verify the price for 5 pounds. So you're going to have to multiply numerator and denominator by 5. So whatever your unit rate is times 5, well, if that's $15.50, then C would be true. But I don't know. You're going to have to figure out your unit rate and multiply by 5 and check. What about D? 12 pounds of blueberries cost $33. You're going to use the same strategy as you did in C. You have to take your unit rate, but this time you're going to multiply by 12. If that equals $33, then that is a correct answer. If it doesn't, then that one's wrong. All right, the last one, E. The point 39 is on the graph. So if it is, we could find out by taking y divided by x, which in this case would be 9 divided by 3. If this is equal to the unit rate, then that would be true. If it doesn't, it's not true. Okay, go back. You're definitely going to want to check your work with a calculator. And really, it's all based on this unit rate. Everything's going to come back to that number. So make sure you're using your you're making your calculations accurately. For number 3, if you were doing the makeup test, if you took it after the original date, then you're looking at kind of a weird problem. It's a little bit different than what we were doing. In this case, we're looking at miles per minute. And miles per minute, in that case, this is going to be, or is it minutes per mile? Minutes per mile. This is why I changed it, because it's confusing. Normally, time is x. But in this case, the way they wrote the problem, it's backwards. So, which is fine, because remember we saw that they would be reciprocals of each other. So it's fine. When we write equations, it's usually y equals kx. All you have to do is change the k, which represents your unit rate or your constant of proportionality. How do we find that? You have to take your y divided by x. And I've already labeled it for you, so that should be pretty simple. Y divided by x, and that's your equation. The only difference is that instead of y and x, we were using t and d to represent time and distance. Now, if you took the test on time in class on the day we were supposed to take it, which was, the majority of you, I did change this problem a little bit. So instead of 1 mile in 5 minutes, we changed it to, let me make sure I have that right, 4 miles in 20 minutes. 4 miles per 20 minutes. So when we changed it, I said we're going to make time x, which is normal. Well, not normal, but more often than not, you'll see that time is x. Anyway, because I changed that, I had to change my equations. Not a huge change, but a little bit of a change. Well, this is a big change. Anyway, again, our equations are written as y equals kx. Our k is the constant of proportionality, which is found by dividing y divided by x. So just make sure you're using the right numbers. Divide, simplify. Always simplify. People always ask, we have to simplify, Mrs. Spencer? Yes, always. Always simplify. Okay, that was number 3. Number 4, the two lines represent the amount of water over time in 2 tanks that are the same size. Which one fills more quickly? Explain how you know. So 2 questions here. First, which one is filling more quickly? And then you have to explain. So the best way to do this is to pick a random point on the line. So I'm going to pick here for A. Okay? And then I'm going to draw a line straight down to the minutes, which is on my x-axis, and I'm going to say that's 5 minutes. I could really make it anything, but, I like 5. Notice that B is here. So at 5 minutes, B is filling. Look, this is water in gallons. So, I don't know, we can make that also 5, and then this one's at 10-ish, right? I mean, I can really make up any scale I want. But what you want to notice is at that same moment in time, who has more gallons? Well, that tells you which container is filling more quickly. And when you do your explanation, refer to that at X minutes, at 5 minutes, you can talk about how many gallons A has, how many gallons B has, and which one is more. On number 5, the table shows the weights of the apples at a grocery store. Why won't it let me move it? There we go. Sorry. Complete the table so there's a proportional relationship between the number of apples and their weight. Well, this whole proportional piece tells me that I can find the amount for 1 by dividing y over x. That gives us our constant of proportionality, or your unit rate. So we only have 1 to work with. So to find that, we're going to divide 0.6 or 0.60 divided by 5. Because this is x, and this is y, and we divide y divided by x. Once we know that number, and you're going to have to divide to figure it out yourself, but whatever that number is, all you have to do is multiply that times each of your x's. So I'll say times the constant of proportionality, and that gives you your answer for the weight in kilograms. Because remember, y is the constant of proportionality times whatever x is. Well, in this case, x is 2. So 2 times the constant of proportionality gives you your y, or the weight in kilograms. And you can check here, make sure it works. So 5 times whatever that constant of proportionality is should equal 0.6. If it doesn't, you need to go back because you made a mistake somewhere. Again, for 12, all you have to do is multiply by your constant of proportionality, and that will give you the weight in kilograms. For number 6, they give you this equation, and this was actually part of our notes. This equation, F equals 9/5 C plus 32. This relates temperature measured in degrees Celsius, which is the C, to degrees Fahrenheit, which is the F. All they're asking you is whether or not that equation represents a proportional relationship between C and F. Well, remember, our equation for proportional relationships is y equals kx. Nothing is being added here. Nothing is being subtracted here. It's just constant of proportionality times an x value. That's it. So if the equation contains any other operations, it automatically is no longer a proportional relationship. Okay, so I think you can deduce that one on your own from there. All right, last problem. This was kind of a doozy. It had a lot of pieces. So let's look at what it tells me in the directions first. So it says a recipe for salad dressing calls for 3 tablespoons of oil. 3 tablespoons of oil for every 2 tablespoons of vinegar. Tablespoons, I'll just call it V for vinegar. The line represents the relationship between the amount of oil and the amount of vinegar needed to make salad dressing according to this recipe, and they give us a point on the line. So the main mistake I saw here were people were mixing up where the oil goes and where the vinegar goes. Well, based on what we were told, there's going to be more oil than vinegar. So if we look at the point 1.5 over 1, right, because that's your x, that's your y. Our unit rate or our constant of proportionality is y over x. Well, the 1.5 is bigger, so this has to be oil. And the 2 tablespoons of vinegar, well, that has to be in the denominator. Does that make sense? If you multiply this by 2, you get the 3. If you multiply this by 2, you get the 2. So that means the y-axis should have the oil, and the x-axis would have the other one. So that was part A. All you had to do was write oil on one of your axes and vinegar on the other. For B, it's asking you to write an equation to show this relationship. Indicate the meaning of each variable. Literally nobody answered that, so I didn't even count that. So we're just that should have been listed separately, or I should have highlighted it for you. So because it was clearly miscommunication, I'm not counting it. So let's just look at the relationship. Y equals kx. All you have to do is replace the constant of proportionality. What is your constant of proportionality? It's your y divided by x, which we talked about earlier. I'm giving away answers here. I'm giving away answers. My apologies. So y divided by x. Okay, and you can also see it. Well, you can see it down here too. Y divided by x. So instead of y equals kx, you're going to do y equals constant of proportionality, x. Finally, explain the meaning of the point 1, 1.5 in terms of the situation. So in terms of the situation, I'm asking you, well, how much oil and how much vinegar? And this is in tablespoons. So your explanation should say 1.5 tablespoons of either oil or vinegar for every 1 tablespoon of oil or vinegar. So we're still talking about y over x. You should have already labeled your axes so you can see which one is oil and which one is vinegar. Okay, that was it. I hope this helps you with your test corrections. If you have any other questions, I'm always here for you. Good luck.